to go very quickly through the way we could use Weave, which is a package for Julia to write reproducible documents. If you use things like knitr in R or PyWeave in Python, it's sort of the same thing, and the principle is that you write a document using Markdown, which is a very simple syntax for text, and that is then processed into something where the code is executed. So when you want to use Weave, the file extension is usually .gmd, which stands for Julia Markdown, and it's quite simply a Markdown file with some Julia code thrown in. So let's go with a simple example. We can write a title, call that demo Weave document. We could write the name of the author here, and we could write the date, which is 2021/02/16. This entire block here is what is called the header of the document, and it's a way of specifying some metadata. So we can have the title, we can have the author, we can have the date, we could have some additional information that are going to be passed to the Weave package. Or if you use your own template to generate the document, you could have any additional information that is required. So using Weave requires a text that is written in Markdown, and Markdown is a very simple specification for text. So what is Markdown? Markdown is a way to write things like italics, bold, titles, list, definition, bibliographic references using only text. So it's different from a text processor in that it is based on code. You are specifying what you want to do, not what the thing should look like. And there is a second step, which is processing this document into something that looks like a text. So Markdown is a simple way to specify how text should look like. So it can be italics, or bold, or both. Depending on the text editor that you're using, let me try with, yes, depending on the theme you're using in your text editor, it is going to actually look the way you want it to look. So if you use something that has support for italics or bold or both, it's supposed to be bold and italic, it's going to look like that in the text. It can have lists. Lists can be nested. And it can have other things too, like quotations and mathematics. So the syntax for mathematics is going to be using LaTeX, which lets you write equations that are as fancy and complicated as you want, but that's not really the point. So that is what Markdown is. It's a way of writing text like that, and then the text is going to be processed into something that is looking much better. So this is a subtitle. What is Julia Markdown? So Julia Markdown is a way to have code in addition to text, and to run this code as part of the text. Let's do a quick example. So we are going to use this following syntax, which is 3 backticks and then the name of the programming language that we want to use. So it's the same thing in R or Python. With the 3 backticks and Julia, this is going to be text that is, this is going to be code that is going to be rendered into something else. So let's do a function, which is f is a function of x returning x squared. So yeah, that's fine. Okay. So what we're going to do next is that we want to transform this document into something where the code is going to be executed over time. So to do that, let me start a Julia terminal fairly quickly. We are going to use a package called Weave. So what Weave is doing is offering multiple functions that can either extract the code or extract the text or transform that into a document. And the main function for Weave is called Weave. And we are going to weave the file that is called doc.gmd. There's a lot of things that are going to be happening at this time. First is the usual pre-compilation of that. One thing that Weave does, and it's very interesting, is that it sort of updates you on what is called the chunks. The chunk is a bit of code. So this is a chunk. And so you know that it's weaving chunk 1 from line 26. And so if there is an issue in your code, it's going to stop weaving, or it's going to give you a warning, and so you can track down where the issue is. What is interesting as well is that in the end, it's going to say, I have weaved that to this document and return to you the document that it's being weaved. So let's have a look at where this document is. Let's do open containing folder. It's here. And so what's very neat is with Weave is that it can render things to multiple formats. I'm just going to zoom a little less. Okay, so what we have here is an HTML page that has been generated. For some reason, the 3 star signs for bold italics are not supported. That's fine. But what we can see is we have our metadata here. We have the title, which we also will notice is the title of the web page. So that's nice. We have the name of the author. That's me. We have the date. That is a title, that is a subtitle. We have our math that are rendered correctly. But more importantly, what we have here is the code that we typed in, and then the output, the results of running this code into Julia. So it's been run automatically. So let's keep updating this document so we can now apply this code. So let's have a look at what happens if we do f of 3. That should be somewhere around 9. And then we run this thing again. It doesn't refresh automatically, so we just reload our page. And what we have here is that here is the instruction that we typed in, and then here is the result. And so what is interesting is that we're not keeping track of the result. The document that we have is only storing the code that is required to run the thing. And so you can distribute your code with text as a GMD document. There's an interesting thing that Weave also support, and so Weave also supports what we're going to call like inline evaluation. So if we do a backtick and J for Julia, it is going to replace the content of that, not by a full box of text, but by just the output. So we could do f of 4 equal. Let's try to see if there's a weird interaction with the equation delimiters or not. And we run this. No, we have this thing. We have f of 4 equal 16. So this little block of code here, backtick J, and then the call to the function and another backtick, has been executed as something that is inline. And so we could use that to replace some text. That's fairly important because if you want to do something like we have been running 5,000 simulations, and then you run the thing again with 10,000 simulation, instead of just keeping track of how many you've been running and updating that manually, you could just have a backtick J length of simulation, and that is going to be keeping track of updating the text for you, which is really, really neat. If you do things like statistical testing and you don't want to be manually keeping track of your p-values and degrees of freedom or test statistics, then you could do this inline evaluation as well to have there always up to date. we could also, so we could load any packages that are installed as in any other Julia script, right? So it's going to be taking a little bit more time because using plots will require the usual pre-compilation and all that, but it is going to mean that we could use plots in our document. Of course, everything that we type here is going to also appear in the document. And so maybe we don't want to do that. Maybe we want to hide some of the results. And there is an option for that that we can add after we have specified the language. And so we are going to use echo equal false. Echo is one of these terms that's used across computing to mean say something. So echo is what you use to print the value of a variable in shell, for example. So it's sort of a well-accepted term to say, do I need to show you this thing or not? And so in this case, maybe we don't want to see, maybe we don't want to show all of the packages that we're loading. Depending on if you want someone who is very technically minded is going to be looking at the source of your document, and if you want to just produce a nice report without all of the without showing all of the code or with hiding some of the code that is not necessarily super useful, then you can use echo equal false. There is another option which is called result. It's probably results with an S. I don't know. I keep the documentation open usually, or here. Where it is going to let you know if you want to hide or show the results of something. So if we don't use any of this option, we have like using plots and then nothing here. If we reweave the document, we are going to see this line disappear. So so we use equal false, and then there's no results, and so this line exists. It's been executed, which means that we can do some plots, but it is not shown in the final document. Let's do a plot. So Weave is integrated with a number of Julia plotting packages, plots.jl for sure, Gadfly most likely. So we could do plotf, and remember that with plot we could actually plot over a function. So that's neat. So let's do a little plot real quick. So let me just change the theme because I don't like the default. I don't like the default theme of plots, and I like my plots to have boxes around them. Okay, so what is going to happen now is that the plot that we produce is going to be captured and put into the document. And it's worth paying attention to the way this happens, because that's very interesting, I think. So the first time we run anything plot related, it's obviously going to take a while, but then the next plots are going to be faster. Oh, so one's not too bad. Cool. So now we have a document in which we have the call to the plot and then the plot. One thing that you may notice is that the plot can look a little bit blurry. And so if you have screens that are larger or things that are like Retina screens, 4K screens, whatever, you might want to bump up the resolution of this figure. So let's do that again. Let's increase the resolution. It's going to be a lot more crisp, and it's also going to take the entire size here. So that's, you could do this report that looks nice. It doesn't look pixelated. It's just beautiful, and we love to see it. Another argument that we can use here is, I think, fig cap, and say this is a plot of the function f, sort of like x squared. Let's do that. So what is interesting is that it is meant to, it doesn't really matter. It is meant to produce technical documents, document for science. And in document for science, you usually like to have your figures have a legend. So in the HTML template, let's inspect this element. it is rendered within a figure element. So from a semantic point of view, this web page is created with the fact that this figure, it's not just an image, it is an image with a caption. It's something that has a legend. One thing that is interesting is that the figure is actually represented by a string of text. So it's not saved externally. It is embedded within the web page. So if you want to distribute that to someone, you could give them the HTML file and there are no attachments that are required. I like that very much because it means that it's sort of standalone. You don't need to have a whole folder of things or like, oh, I have the text, but it's missing the figures. Everything is embedded within the file. It tends to create files that are a little bit larger, but it's also far more convenient if you want to distribute this file to other people. And then again, we could use multiple arguments. So we could do echo equal false and say we just want to show the figure and we don't really care about this code. That is something we can do. We could use echo equals false to be hiding the code that is generating the figure. So what is very, very interesting in working with Weave that you can have your document and your code and it's going to be exactly like a script with tons of comments, but then in the end you get something that looks like a report. You could use you could generate a file that is HTML, but you could also generate a file that is a PDF if you have an installation of LaTeX and Pandoc. I think you can also generate a Word document. So why you should want to do that is not something that I fully understand, but you could generate all sorts of file. I sort of like having a file in my browser. I like HTML. I think it's sort of clean enough, but you can also create your own PDF if you want. The website for Weave is fairly well documented, and there are tons of different options that you can use. So I have built websites for courses. My own blog is built on Weave. There's sort of a lot of different things that you can do. There's a lot of different options, especially for figures. It's fairly powerful as a tool. So if you want to use it with none of these functionalities, you can. You just don't need to add any options to the chunks of code. But if you want, you could fine tweak the results of this of what it looks like. So that was a very short introduction to Weave. One thing that I like to do, let me just show you before that, is have a file that I call compile.gl this time. Not because I don't necessarily feel like running things in the terminal all the time. And so we could do things like, let's say we're going to do read_dir. So read_dir is going to give a list of everything that is within the directory, and so we could do something like gmd files equal filter ends with gmd of read_dir. So get a list of all of the gmd files that we have, and then we do weave.gmd files, something like that. So let's say you have, I don't know, a bunch of different files. So you have like one report, you have a supplementary material for your paper, and you have slides. They're all saved as JMD, and you want to compile everything at once. Then you can have this little script. And when you run that, it's going to go through the entire folder. So if you want to use multiple reports for a class and you want to make sure that all of these reports are kept up to date, that is one thing that you can do. So that's the way I usually tend to deal with files. There's quite a lot more to this package. You could also export this document to Jupyter Notebooks. You could export this document to, you could extract the code and have a JL file. The function is called, I want to say tangle. Let's try tangle.gmd. And then we get a file which is called the same name.jl, and that is all of the code that we used. The code that is inline is not going to appear here, but the code that is in a chunk is going to be here. So if you want to turn your report into a code, then you don't need to be selecting the lines manually. You call tangle, and it's going to do that for you. In fact, you know what? Let's just systematize the process a little bit and do tangle.gmd files. And that is something that looks like the sort of compile file that I'm using most of the time. So that was a very short introduction to Weave. It's something that is well worth investing a little bit of time figuring out. And I just love the power of creating reproducible document from within Julia. Bye everyone.